Welcome back, Physics 30. Today's lesson basically concludes Unit D, and at the same time, it concludes everything that we supposed to achieve in this semester. So this is a last component of a lesson. So congratulations, folks. Now we're gonna go very vague field. Even myself, I'm actually not specialized in this field. We're gonna really go into a quantum field. So before we getting into quantum, what does that mean? That means we are trying to find something that is smaller than subatomic particle. So quantum world is actually way smaller than what we learn proton, electron, neutron. In fact, it's a study that identify or try to explore or even investigate what makes these. So if you think about our science journey in high school and junior high a little bit in fact too, quite a lot of people learn it as Dalton's theory of atom is the smallest matter. In high school chemistry too, that is true. But what makes atom is in fact these three subatomic particles. The reason it's called subatomic is sub means lower, so smaller, so under. So subatomic means under the atomic level, what do they have? Proton, electron, neutron. And one thing that we learn in Unit D is proton and neutron make nucleus. Electron easily, freely can go in and out, depends on whether it's emit EMR or absorb EMR. And that's how atom get ionized. And that will be chemistry part. Now, quantum, in the world of physics, we are talking about what makes these. So that is very theoretical part of a lesson. So, last class, we talk about particle accelerator and particle tracks. So, first of all, scientists found that there are hundreds of new subnuclear particles from it. So, we're no longer talk about alpha, beta. We actually go quite more detail. And scientists organize them according to their fundamental forces. And strongest to weakest, they've listed as strong nuclear force is the strongest, followed by electromagnetic force, weak nuclear force, and gravitational force. So this is Unit D, that's Unit B and C. Weak nuclear force, Unit D, this is Physics 20, if you recall what those forces are. Now, and we are excluding black hole and its gravitational force, just for the heads up. So three major categories that you need to know is lepton, which basically makes electron and neutron, hadron, which makes proton and neutron, and hadron is one of the most important one in Unit D because that makes nucleus, field particle, which is photon. So, lepton, electron and neutrinos. The way that you remember these guys is basically from beta negative or beta positive decay. Scientists detect those particles that is emitted. They do not experience strong nuclear force because of one reason. They cannot create nucleus. Electron and neutrinos cannot make that. They have relatively more freedom. Leptons are believed to be true elementary particle with zero size, and the reason it's zero size is because it's way smaller than 1U. So that's why. And no internal structure. But we discovered that, and we're not going to go string theory where everything is in fact made out of string. And that's kind of similar as a de Broglie situation in Unit C, but we're not going to talk about that. But long story short, electron and neutrinos have their charge property, but not much of mass property. Hadrons are the one that we learned so far. These do undergo nuclear force. That means they can be combined together. Field particle, it's more like gamma radiation, if you will. These are the quanta of a different force field, and they basically carry, they're the mediator of the forces. So for example, the reason that photon have an energy is because of E is hf, hc over lambda. I mean, they can transfer force to others or send the energy from one form to another, but they cannot make a matter. Let's put it that way. Now, that leads us to, and this is a tough part, the dark energy and annihilation process. Annihilation process is quite complex. Mathematically, it's not that hard. All subatomic particles have antiparticles. So if there's an electron, there's an antiparticle, positron, something like that. They are identical for every single property, but they have completely opposite nature. So think about yourself and the mirror. Think about that situation. And particles and antiparticles, they collide. If that happens, they completely annihilate to each other. So that means it becomes net zero. The existence will be gone. So when an electron and positron collide, like the one that you see over here, I have negative electron and positive positron, then what's going to happen is when they collide, they will be completely annihilated and have nothing in terms of matter. But energy, think about conservation of energy. You have kinetic energy, you have another kinetic energy. What will that kinetic energy turning into? They turning into gamma. So what scientists find out about this antiparticle is, of course, it was random, if you will, and then it was founded as a surprising phenomena. They found that electron disappear. So that means whatever that EMC squared, you can find that that energy should be turning into basically our photon energy, right? So if I have a 30 electrovolt, then I should experience 30 electrovolt to be detected as a gamma particle. But the surprising thing is, they figure double. They found, if it was 30 electrovolt, they found 60 electrovolt as a gamma photon. And that made them think about this antimatter, because that's the only way you can produce one and the another. There is a positive nature and negative nature, so that's why if they collide, that's a double the impact, if you can think it of that way. So, in your conservation energy situation, imagine this is initial part, final part. Initially, we have two MC delta, MC square situation. Again, in this case, one negative, one positive, so electron and positron, which is exactly the reason why you have two, double the amount of gamma radiation that's happened, and that's HF or HC over lambda multiplied by 2, depends on what the question asks you. So the way that this doubling happened is because one electron, one positron, so one matter, one antimatter. That's why things were discovered as double. So let's do a quick example in using this scenario. A proton and an antiproton collide and two gamma photons are produced. Determine the frequency of the gamma photon. So let's think about energy perspective. Actually, I'm going to use sigma. We have initial versus final situation. Initially, you have mc square of proton plus mc square for your antiproton. And that gives you HF to HF. But the thing is, those two are identical in size, so if you actually cancel one of the property, then you will have delta M proton C squared should be equal to HF. That is purely one part proton's perspective. So, and complete annihilation means delta M is my proton's mass, the total mass. So if I isolate for F in here, and we're gonna kinetic energy at the first, so that it's high school scenario related. F is equal to delta M P plus C squared over H. Then frequency is 1.67, 10 to the power of negative 27 kilogram, 3, 10 to the power of 8, double, H 6.63, 10 to the power of negative 34, something like that. And that's in hertz, of course. So, let's punch those numbers in. You have 2.27, 10 to the power of 23 hertz, and that gigantic amount of frequency is what we should detect on one side, and the other side we should expect the same amount from antimatter. That is where the antiparticle is coming out. Isn't that quite amazing? The funny thing is we couldn't see those, we cannot see that, but we detect it somehow. So scientists, physicists, they create a theory. Now our last concept, quarks. So quantum area, and what's the quark? Quark basically means what makes electron, proton, and neutron. Especially hadron is the one. Hadron are composed of even smaller particle called quarks. And those quarks is the reason why proton and neutron have positive charge or no charge. To account for the internal structure of neutron and proton, there are two types of quark, up and down. Now, the thing is, we need to think about antimatter of that too. Antimatter, if you go from up and down to there, is anti-up, anti-down. That is also possible. So for example, up, in this case, is positive 2 over 3. That means anti-up is negative 2 over 3 charge. If it's down, that gives you negative 1 over 3. Then anti-down is positive 1 over 3 electric charge, something like that. So how does this up quark and down quark combine together to make proton, basically? And the other quark, of course, there are several weird names like strange, S, charmed, C, bottom or beauty, B, and top or truth. But these are way beyond high school. So even if it's come out as a scenario, you will expect it as, you will expect some kind of information that describe those. But all quarks have a corresponding antiparticle, and that is very, very significant. Like I mentioned, anti-up and anti-down over here. So proton is UUD. Let's figure out why it's UUD. Because U is 2 over 3 positive plus U, again, 2 over 3 plus D, negative 1 over 3. If I add everything up, 2 plus 2, that's 4. 4 minus 1 is 3, so 3 over 3 with fundamental charge that is happening. So they simplify, and then you have 1E, positive E. So that's why proton have that 1.60 10 to the power of negative 19. So if you actually think about what's my up, then it's 1.60 10 to the power of negative 19. And then from there, you just need to multiply by 2 over 3. So 1.067 10 to the power of negative 19 is about the charge of up quark. So proton have up, up, down combined together inside of it. That make a proton. Neutron, on the other hand, same type of calculation, it's addition. So this part is really easy. 2 over 3 plus negative 1 over 3 plus negative 1 over 3. As you may notice, this is positive 2, these two make negative 2. So in the end, it's 0 over 3, which make 0 charge. Thus, neutron is literally neutral. have no net charge. That's how we calculate things using quark. Let's do a quick example. Determine the charge of pi meson, and that's pion with the pi symbol, and it says it's composed of anti-up and d. So UD means basically up was positive 2 over 3, which means opposite charge negative 2 over 3 E plus down is negative 1 over 3 E. So you have negative 3 over 3 E, which is simplify as negative 1 E or negative E. So that means pi meson have completely identical charge property as an electron. That's basically what you can think about. Now, how did this can be applied for unit D? Basically, we're gonna revisit beta decay. There was a beta negative, beta positive. In diploma, it's always asked in this way. And that rather explain a little bit of a antineutrino and why antineutrino for negative or neutrino for positive was detected is because that's what scientists discover, and then we are trying to identify what that is. First thing first, UDD. This is like neutron. You have zero charge, so it's a conservation of charge that we are talking about in both of the scenario, by the way. Some people may say, Mr. Kim, but we have some kind of atom with a different number of neutron and proton. So it's some may say, Mr. Kim, that means we're only talking about neutron. No, it's not. We're talking about that in a perspective of quarks. I'm not talking about uranium 200 something in here. But in any case, if I think about the whole process, beta negative is negative 1. This guy doesn't have any charge. So that means, how can I make this unknown X, which is my daughter nucleus? There's only one way. Make that as positive, which is UUD. So beta negative have UDD on the left side and UUD on the other side. There's no antimatter at this situation. And from this process, one part of D basically turning into U. That's a quantum level of looking at how the nuclear decay that has happened. It's not the whole thing that changed, it's just one of the quark changes form. And from this process, I emit electron and antineutrino through that process. So basically, that means beta negative is caused by neutron decay into proton. And that's the reason why beta negative and antineutrino was found out. Same thing, but differently, beta positive. It's positron plus 1. This guy have nothing. Now, if I look at my X, you need to understand that my parents UUD, which is positive 1 to start with, then I already have positive 1 and positive 1. So there is only one way. That becomes 0, UDD. So when it comes to positron, it's opposite. Instead of D turning into U turning into D, and from that process, we have positron and neutrinos coming out. So it is important to understand the conservation of charge to do that process. Ladies and gentlemen, that is everything related to Physics 30. Yay! So I want you to do both A part and B part of the homework, which is on page 30 and page 31. And thank you for following my course throughout this semester. I hope you had a good knowledge, and then it is a challenging course. I hope you do well for the diploma. For whoever who listened this after this COVID-19 situation. COVID-19 was the reason why I made this video, and I'm glad that I digitalized all of my Physics 30 lesson into multimedia format. For students who look at this, which is Brienne and Ryan, if you look at this in 2020, due to a COVID-19, we're in quarantine situation. However, I hope you guys do well in the post-secondary, and hope you whenever you pass by Mr. Kim in Edmonton, something like that, please say hi. Don't ignore me. You guys can do well.